Welcome to separable equations. So a quick definition, a first order differential equation is said to be separable if it can be written in the form y prime is equal to some function of x, say f of x, divided by some function of y, say g of y. So equivalently, g of y times y prime is equal to f of x. Okay. So this is, we call the differential equation to be separable if it's in this case. So for example, let's go ahead and show that the differential equation 2xy times y prime minus 3x squared y equals 6x squared y squared is separable. So anytime we have a differential equation and we're trying to separate the variables, the very first step is to move all terms with y prime to one side. And all other terms to the other. So in this case, we have a 2xy times y prime on the left is equal to 3x squared y plus 6x squared y squared on the right. Our step 2 is to try to factor both sides so that each factor contains only x or only y. So try to factor each side so that the individual factors are in one variable. So our left-hand side is fully factored already. We have a 2x times y prime. The right-hand side, we can go ahead and factor out a 3x squared. We are left with a y plus 2y squared. And then divide the right side by any factors containing y, divide the left side by any factors containing x. So we divide by any left factors in x and right factors in y. And we wind up with, we keep the y prime on the left, but now we are dividing by a y plus 2y squared. On the right-hand side, we have our 3x squared, and we divide by 2x. We could, of course, simplify at this point if we wanted, but we have all of our y's on the left. I'm going to just shift the y side over so I can put the y prime afterwards. So we have y over y plus 2y squared times y prime after the fraction equals 3x squared over 2x. So in this case, here we have essentially a function of y times y prime is equal to a function of x. So now what do we have here? Now we get into the theory. So if an equation is separable, then we can rewrite it in the format g of y times y prime is equal to f of x. And so again, while our original definition was y prime equals f of x over g of y, we could rewrite it in this alternative form. From here, what if we then integrate both sides with respect to x? Then we get that the integral of g of y times y prime dx is equal to the integral of f of x dx. But y prime times dx is just dy dx times dx, which is just dy when we work with differentials. And so we therefore get that the integral of g of y, or so the equation becomes the integral of g of y dy is equal to the integral of f of x dx. So essentially, if our equation is separable, we can just separate this into two separate integrals, one in y and one in x. Right? So from here, then we can integrate each side separately. So these equations are considered to be separable because we can completely separate the variables and have one integral in y and one integral in x. So for example, let's go ahead and find the general solution to 3x minus 2 times y prime equals 1 over y squared minus 2. So the language here, general solution, recall I mentioned in the previous video, we can have infinitely many solutions. So this is the sort of the general format. For all solutions is what we're looking for. So if we have 3x minus 2 all times y prime equals 1 over y squared minus 2, this equation is equivalent to y squared minus 2 times y prime is equal to 1 over 3x minus 2. So the first thing we did was separate the variables. I'm actually going to slide this down and write that as step 1. So step 1 is to separate the variables. So we have g of y times y prime is equal to f of x. Our step 2 then is to integrate both sides. So we have the integral of y squared minus 2 times y prime dx is equal to the integral of 1 over 3x minus 2 dx, or definite integral of, the integral of y squared minus 2 dy is equal to the integral of 1 over 3x minus 2 dx. Integrating the left-hand side, we have 1/3 y cubed minus 2y plus what I'm going to call c1. On the right-hand side, if we integrate with respect to x, integral of 1 over 3x minus 2 dx, we are looking at a 1/3 times the natural log of the absolute value of 3x minus 2 plus c2. If we set c equal to c2 minus c1, then we have 1/3 y cubed minus 2y is equal to 1/3 times the natural log of the absolute value of 3x minus 2 plus c. So separable equations, sometimes our solution is not in explicit form. Here we get an implicitly defined solution. That's acceptable at this point completely. So we have an equation for relating y and x. It's technically not currently written in function form. So this is how we can work with separable equations. In the next video, we'll go ahead and do a slightly more complicated separable equation. And then we'll get into IVPs involving separable equations.